many scenarios where IoT will play a role. Starting from the production of the goods, starting from the consumer potentially, where you want to track how have my goods been shipped? Have they been shipped under good conditions? I bought things that have the logo of fair trade. Is it effectively fair trade? I've been buying some timber or lumber. Is it a qualified type of wood? I've been buying livestock. Does it have the vaccinations? Does it have the health certificates? These are all types of IoT scenarios. And then there's also the physical security. If you do shipments of goods, you want to track these goods, you want to know where they are, you want to know in what state they are, but you also want to protect access to it. So strong authentication, strong security, multi-factor authentication, facial recognition of a person that is authorized to go into a warehouse. If he goes in a warehouse, does he wear a helmet? Forbids him to enter or generate warnings if he's entering without helmet. All these type of technologies become reality. If you see a vessel coming into a certain maritime area and it is doing an encounter at sea, we see adoptions by the European Maritime Safety Agency, for example, sending out a drone and using a drone with a high-definition camera with real-time vision technologies, doing the almost in-place inspection of what is happening between these two vessels using drone technology. And this morning I also demonstrated, and you can see that on our booth, how we can use what we call augmented reality. If you do a physical inspection, you potentially want to see the real world augmented with additional information that is coming from the back office. What is supposed to be there versus what is there. Give guidance to the customs officer what should be inspected. So that was a little repetition on the IoT, but I think it's important to put it in the scenario, capturing the information digitally, capturing the paper-based type of information in a usable format and combining it with IoT information in order to do smart things with it. And the smart things we want to do with it is building risk management frameworks. We want to combine many sources of information together. And we have open source type of information coming from all kinds of type of organizations, like the maritime traffic is a very well-known one in the maritime, versus commercially available private sector information. And I think Deloitte is there another type of example. But coming back to IT, GPS, satellite type of information becomes important and critical as well to merge it all together in something that makes sense to do risk analytics. And if you can merge that information together and then you can draw a triangle somewhere in an area, a maritime area, and you have real-time or near real-time insight on the vessels that in that area, and you can real-time or near real-time get an indication, a record, you see that on the bottom of the screen with a URL, on the details of the vessel, with all its risk information. This is what we want to achieve from a risk management perspective in doing that. But that is still all reactive information. What we want to do in the end is use that information, store that information, and based on that information, take intelligent actions. And I think there is something here with the animation, but we want to build on data sets to take intelligent actions. Now, for that, we have to be able to share data in a federated way. We have to be able to potentially summarize data for relevant industry, customs, a private sector, other types of organizations. So there we see an approach in technology, open source technology, that is typically referred to as data lake. Data lake is a Hadoop type of file system, so it's completely open source that allows you to inject, in fact, any type of information. Structured data, unstructured data, pictures, IoT information. And why is this important? Well, typically people tend to store this information in files or in databases. Both of these storage mechanisms are very inflexible and very expensive. So if you go for an open platform that is very cheap to store data, you can also start to think about keeping your data longer. Having more data. And why will that be important? Well, if you want to classify things and you want to create a reputation, you want to create green line versus red line type of situations, you will have to build on historical data. And so we believe very much that the data lake approach is an approach where you can store any format of data, you can secure it, and you can give granular type of access to different industries that need it. It's cross-platform, it's open source, so it's not locking in, it's not mandating any platform from that angle. So it's a very reusable solution from that perspective. We also have global databases which allow you to use database technologies, but personally I think that a data lake approach is as good, maybe better approach, but if you have MongoDB or you have Cassandra or you have Gremlin or you have JavaScript type of application, these global databases now also exist and allow you to store that information. Now we store the information for the purpose of applying intelligence on it, extracting intelligence from it. And that is a process that will be done with AI and machine learning, where we want to detect the patterns, the connections, the relationships to predict things. And predicting things can be predicting the arrival, predicting the security risk score of goods that arrive, but it's things that you will use to take actions at a later stage, so to predict the future. This is an example of, I'm continuing a bit here on the maritime space, where combining reputation, the fact that there was an encounter at sea, a change of speed, a change of route, information of the bill of lading, the meteorology conditions, there is wind, there is a thunderstorm, provide a dynamic risk scoring in an area, predict when vessels, for example, will arrive or should arrive at a certain position. And if they don't arrive at that position at the predicted time, to generate a kind of risk alert and to investigate why is that truck, vessel, airplane not arriving at the moment that it was supposed to be arrive. And so AI will help in making these predictions. And here on this slide you see in fact the real time, which are the black arrows. This is what the route is, the effective route is, and the yellow lines are what the AI algorithms had predicted. And again, if a ship derives from its expected route at a certain moment, you can start to generate alerts. Now there are many ships. It's easy to think about these 15 ships that you saw on the previous slide, but this example shows you here that at a certain moment, one control room was able to get that information about 36,427 ships in real time. And to do this, you need a lot of capacity. And that's the other thing, you need a lot of data and you will need a lot of capacity to build out these real-time type of risk management systems. It's getting more critical if you move into aviation, because planes have tendency to move much faster than vessels, and so you have to update your information not once every minute, or we talk about multiple updates per second per plane. So performance for that will be really important, and being able to store and process that data will be important. Now, if we look at technology further, a lot of things in the trade process is about recognizing goods, recognizing counterfeit versus genuine, recognizing in cargo livestock, people, arms, drugs. So you have to be able to tell the system, to teach the technology what you want it to discover by looking through X-rays, through cameras, at objects. Any IoT type of object, any freight, any cargo, any container, and so on and so on. We call that the cognitive services, and they can really see the world. They can read text, they can translate text. I already showed you that in the beginning of my presentation. But if we combine this with vision, they can see this is a printer. And they give you a JSON type of feedback. This is a printer, and the technology can even read what is on the printer. So it reads the labels, it reads what is on the paper, it recognizes the text. And it helps you to detect this object in an automatic way. If this was the object that you expected, this is fine. If it's not the object that you expected, or there are more objects than what you expected in that freight or in that box, you might generate an alert again here. Now on the left side of the slide, you see another type of example here where we have trained the system in a very different context to recognize what is in a fridge. So you open the door and you have a device that can look at the content of your fridge, and it will say you have tomatoes in it, you have a bottle of fruit juice in it, you have paprikas in it, and you have a bottle of orange which is half empty. How do you do that? How do you use such a technology? Well, you deploy it on cameras to do site inspection, to do pattern detection, to do all kinds of car plate detection. You train again a model to recognize the objects you want to recognize. And then you deploy it in a Docker container. This camera is running a Docker container. So it has a microcontroller built in that allows you to deploy Docker containers. And then you can manage them with Kubernetes or other type of technologies if you have multiple of these cameras and you have to connect them together. This technology is used in industry as well. It's used to look at, for example, a hardware technology, if it's Jenny or counterfeit type of technology in an automatic way. And this technology can scan many of these parts per second. If you do that to humans, they will get tired, they will make mistakes, while this technology maybe makes mistakes, but it will never get tired at least. The same thing here. If you use infrared technology, you can look through and you can see that on the motorcycle, if you only look at the left side, you see one person. But if you look with technology at the same object, you see in fact that the backpack is containing a human person. The same with the car. You can see in the car that there is a second person. And that's similar type of training you can give to your algorithms to detect radiation, explosives, or other types of things. If you look at the CRUX solution, the CRUX solution from Smiths Detection, they have applied this technology in their scanners. So their scanners will take images, and our technology has been trained to recognize what Smiths Detection believes is useful to detect when you check in your luggage at an airport, when you pass security at the airport, when you load cargo in a plane. These are different models, but because you use an imaging technology, and there's also a standardization for that format, that imaging format undergoing, you can, based on combining information, where is the cargo coming from? Are the documents correct? Was there a pre-notification? What was on the bill of lading? Plus, what do I see on the scanned RX image? If you merge that information together, this type of technology can automatically give the freight, the container, the box, the passenger, the label of a luggage that is checked into an airport and an airplane, a risk score, a risk label. And then it's up to the airport security or the customs to take actions based on the fact that there is a risk score that, for example, is above 5 or above 6, depending on your business logic that you have applied. Now, a lot of things are tracked and traced and are validated, are attested using blockchain. And somebody said this yesterday, I think, during a session. Blockchain looks like a great solution looking for candidate projects. Well, I think there are a lot of scenarios already used, especially by industry, to do provenance checking, to do certificate of origin validation, to do environment monitoring, to do identity management. And this is an example where Mars Food is using, in fact, blockchain to attest, in fact, every critical step in their trade process. And of course, they don't use consumer type of blockchain technology. They use enterprise deployments that can manage multiple transactions per second. Because you hear a lot of FUD about blockchain. If you use the consumer version of blockchain, it can take up to 10 minutes before a transaction gets committed in all the ledgers of the blockchain. So therefore, we have enterprise deployments that can do thousands of transactions per second. and you build out a consortium with your industry partners, and they will get the possibility to check the attestation that have been done through the consortium. Here is another example on a grain producer that uses the Vision API. So they scan, first of all the grains, and they reject all the grains that doesn't conform to the quality norms. This is done automatically by machines using that same camera type of technology, RX type of technology. They train the system to recognize good and bad grains. They give an attestation through blockchain. They package it, they use multi-layer RFID and QR code packaging, and they ship the goods. And the goods go up to the manufacturer, and in the manufacturing there might be an issue with the production conditions. The temperature is too hot, there's something wrong. Well, this will be attested again, has to be attested, and the buyer of the product will at that moment be able to refuse the products, the goods, by checking the status, the latest status of the goods in a ledger. Payments. Every trade transaction needs a payment. Well, if you can use blockchain for that, you can exclude all intermediates. That's another example. I will not detail too much on this. But another interesting scenario is customs have often the question, what do we do with 3D printing? Because you don't have to ship your goods necessarily anymore physically. You can ship your goods virtually, sending out a 3D printable model using simple email or other types of technologies. And it's completely invisible from a customs perspective if it goes that way. So you can use blockchain if you do this and have every file, 3D file, have a digital unique stamp, including a QR code or other technology that will be printed on the object. And then there is technology, digital rights management technology. The file is transferred over the internet. The company here working on vessel parts and on airplane parts, they are using a titanium printer to print the parts. Well, that will generate an attestation on the blockchain that that part has been printed. That gives, of course, a sign to the producer of the part that that part is now installed in that plane, so traceability of the part, which becomes important, but it can also signal to customs there has been a digital import-export process of a good that is a part of a plane that has been printed by that company. And that is what we do here with blockchain together with MOOC. So these are some examples. If you are interested, we have more examples on our booth on how we use blockchain in very innovative scenarios in trade and customs. Next part is we have now all that data. We can follow, we can recognize the data, we can potentially track the data. Now we have to connect the stakeholders together. And when we look at that process, there we see a real conflict between the private sector and the customs. There's no trust. The customs need to access to the information, but the industry does not trust or does not want to give its information for certain reasons to the public sector organizations. Because there is no guarantee that the data will be used, will not be stolen by competitors, and that is true for the private sector as well. That is technology protection, data protection thing. So what we do here is, or what we believe here is that instead of exchanging that information in a kind of multi-mesh information system where nobody trusts nobody except on a one-to-one relationship, is to apply the single window type of approach where we say, well, let's build a trust zone in which we can federate access to our data. And I expose in the trust zone my data that is needed for that transaction, and the customs consume the data that they need to do risk management, tariff management, whatever they need to do. So I only give temporary consent to access my data in the trust zone. And that trust zone can be supervised by a trustee, which is then a kind of agency that can look at that process. And this gives you the possibility to federate any data source with any data provider. How do you deploy such a technology? Well, a lot of things will use, as I already said, unlimited or need unlimited capacity. So we strongly believe at Microsoft that cloud is a way to go. But cloud is not necessarily a place. Cloud is a deployment model. Cloud is a development model. Cloud is an operations model. That can be public cloud, and that can be private cloud. That can go up to the camera that you saw, the scanners that you saw, can be part of the edge computing running the same technology that you would use on any platform. We provide this technology, which is called Azure Stack. Azure Stack is in fact a copy of our public cloud that you run on premise. So if you cannot use cloud, or you do not want to use cloud, or you're not authorized to use cloud, well, you still can use cloud on premise and do exactly the same. Of course, you will have to buy the hardware for that. Yeah, so this is the hardware type of solution, but the operating system type of technology is similar to what we run in our public cloud. And at that moment, you can use the cloud as a development environment, a test environment, and run your production environment on premise. You can use the cloud as a backup data center. In case you have a major failure in your data center, this can be mirrored because it's completely symmetric. All the applications that run in the public cloud will run on Azure Stack. Everything that runs on Azure Stack will run in Azure. So it's completely symmetric, and you can even think about stretching, having parts of your application on-premise and parts of your application in the public cloud. And that is the scenario that I wanted to show you here. Cloud is not necessarily a place. It's a development methodology, it's an operations methodology, it's a deployment strategy. And you have choices. And I think that is important to understand. So conclusions. We strongly believe that cloud will change the world. For AI, for machine learning, for unlimited capacity needs that will grow over time. If you look at the number of IoT devices and the number of zettabytes of data that they will produce, it will be hard, if not impossible, for the private sector and for customers to host that in a private data center. But that's our vision. As I mentioned, you can also use this on-premise using other technologies. Data is the new currency. So having analytics on all kinds of data, speech, text, images, as I discussed, becomes critical. Doing things with that data, being predictive with that data, is very probably needed and the basis for a lot of innovation. So rethinking the way you collect data, rethinking the way you process data, rethinking the way you share data across industry is, I think, what is needed to get to the latest and greatest technology solutions for customs and trade. And with that, I want to end my presentation. I've been signed that I used all my time. So thank you.
Thank you so much, Frank. And Frank is very well known to the WCO, a friend of the WCO that is often with us. The next presenter is Neelima Pamulapati. She's a technology consultant at GETS CrimsonLogic, and she will be telling us more about single window. It's time to embrace technology convergence. So if we can have the slides for the next presentation on the screen, please. And I would like to remind all the delegates that we have continuous refreshment breaks outside, which doesn't mean for you to leave all now, but at some point during the session you are welcome to go and take a coffee or tea outside the room. So Neelima, you have the floor now.
Thank you. Good afternoon, everyone. Thank you very much for joining this session. Frank has pretty much covered top 10 Gartner digital technologies. So I will bring back a bit pre-internet era to explain how the single window has evolved. Okay, so let's go with the basic definition of what is single window. Single window aims to facilitate exchange of trade information with governments and among government agencies in order to get the clearances, permits, and also the licenses and so on. So there are different models that we are familiar, like for example, single authority model or interface model with different government agencies, or integrated with OGAs where they already have systems. So there are different types of models. That's more or less today the single window has. So bringing back to the single window evaluation, initially it started with the isolated systems where it's a the paperless trade, where we just use the LAN connections, and then coming back to the connected systems where we pretty much leverage on the WAN technologies. So in various evolution, we are leveraging on the technologies that are available at that stage. So now with national single windows, where we pretty much leverage on web services and standard message exchanging formats. So with this, we have multiple single windows, especially for the regulatory. They have this customs-oriented, transport and trade-oriented regulatory single windows. And on top of it, we also have different models, port community systems, e-trade, and e-freight systems. So within a country, there are multiple systems, and there are also regional single window systems that connect across the borders. So there are pretty much challenge, whereas the traders have to use multiple systems to get a clearance. So I have prepared a simple, the basic challenges here. For example, traders and logistics providers need to submit same set of data in multiple systems, and they have to spend a fair bit of time in collating this data to fill the regulatory compliance forms, and often it leads to human errors because manual filling and all that. And to integrate with various systems, we also expect system owners to comply to certain standards to integrate with these systems. And also there is this overload of information. There's so much of information to learn the process and procedures to get a clearance. So these days we can see trade portals and so on, but there are also multiple places where they can find information. There is to find a simple process, traders are forced to read so much of data. So these are the few challenges that we would like to address with our new system, the platform that we have launched today, which is a single window mesh platform. So what it does and what it means. So in a simple layman terms, it leverages on AI, RPA, and deep learning algorithms to extract the information dynamically from structured and unstructured data that is connected to the mesh. So it leverages on all this natural process language for providing interactive sessions to the client, and also blockchain for the security aspects. And we also have deep learning algorithm to aggregate the data and associate, and machine learning algorithms are also being used in the system. So in mesh, okay, this is the architecture diagram. I make it simple. So what we are doing is we have a more interactive in terms of web interaction. It leverages on service-oriented architecture, and we have microservices enabled and cloud native, and it provides open APIs for the systems that needs to be integrated with the mesh, and it leverages on RPA. We have some agents and prepackaged codes to connect with the mesh. So these are the 3-4 components that addresses the challenges that I have described in my previous slides: automation and data-driven decision making. So what it means, it leverages on RPA, robotic process automation, and artificial intelligence. The systems that are connected to the mesh can able to extract the information from various systems, and it can associate, not just aggregate the data, but it also can associate the data to fill the regulatory forms. So for example, if there is an invoice and packaging list, mesh can able to fill the regulatory document information, declaration information, and can find what is the information that is missing from these documents that it has collected, and alert the trader to fill the information that is required for the submission. So this is one part of it where we use the automation. So for example, if let's say a trader receives invoice in an email, our agent can read from his emails and extract the invoice information. And if let's say he has an ERP system that is connected to mesh, we also can, the mesh agent also reads the information from the ERP system for packaging list, and from freight forwarders it can collect bill of ladings or airway bill, and also OGA systems for licenses and permits. So it fills the whole declaration form. As you all know, declaration itself has like more than 50 plus fields. So it helps in terms of automation because it's a basic step in and this information is readily available in all these different files. So we also use cognitive document automation for the data-driven decision making. So what I mean by this is it recognizes if let's say a trader submit an arrival report or manifest in our mesh, so it will check against other systems that are connected to the mesh to find whether there is any associated invoice or packaging list to trigger an action to create a cargo declaration. So it will prepare the cargo declaration for the trader, and if all the information is available in the mesh, it can even submit. But at this stage, initially, we expect user to come in and verify before submission. And if let's say any of this information is missing, as I mentioned earlier, it can trigger alerts to the trader to come to log in to fill the information. That's on data driven. And when it comes to interoperability, we leverage on machine learning and open APIs. So it's what the basic objective or the key objective that we want to achieve in the mesh is one of it is the interoperability. We want to make it as easy as possible for the system owners to connect to our mesh. So how we are able to achieve is we comply to standard protocols. So our mesh is complied to web services like SOAP, REST, or FTPs, and so on. So it complies to all these multiple protocols. And mesh agent extracts the information. So we have a trained algorithms here that actually extract the most common or the mandatory fields that are required and maps to the destination format that is required. So and also it comes with the prepackaged integration builds that can be downloaded and can easily interact. So for this, we expect traders not required to make any further changes to their system to integrate to the mesh. And we also accept the different standard formats, XML, IDOC, EDI files, or GAUS, all these different formats we can accept. And then our mesh will take care of converting those files into the required format by the mesh. So for example, if a shipping agent has an Excel file or a freight forwarder has an XML file or IDOC file, any of these different formats, in our integration layer, we have a AI agent that can extract the information and then format in a way that is required by the mesh or the system where we file the submissions. And like JSON objects, it can convert to the XML. So it will the system will map to the required formats, even the data fields and so on. So the other key objective is the 360-degree risk analysis. So this is how we does this is the mesh actually triggers the risk profiling at the source. So once the packaging list or even the early stage of supply chain, when we found the data there, we will run our advanced analytics engine to do a 360 degrees risk analysis and provide a complete visibility to the traders and also to the customs authorities. So having an accurate information is useful, and also it makes more efficient in terms of the risk analysis. So to go a bit deeper, we have 4 dimensions of risk analysis in our advanced analytics risk engine. Network analysis is one of it. What it does is it extracts the information and checks against the blacklisted entities or the traders, and we create a gray list. So it checks the association of the blacklisted entities, and we also have anomaly detection where it identifies the unusual behavior of the trader. So, for example, if the trader is importing certain type of goods and suddenly there is a change in the commodity that he's importing, or it checks the unusual behavior and alerts the system. And our risk analysis also shows all these 4 different dimensions and probability, and based on the high number of probability, it will trigger the alerts to check which is the high risk shipment. So then we also have a real-time customer engagement models, which is nothing. To provide the real-time customer engagement, we are using virtual assistants, chatbots, which leverages on natural process languages, and also it provides a context-based responses. So not just the data that we prepare the chatbot to answer, but also it checks the real-time information based on the question that is asked to the chatbot. So for example, the trader can ask if he is going into a new market and he wants to know what are the FTAs applied to that particular market, or what is the HS code that he needs to use for his commodities. All this simple, or they can even ask what is the process to import and export. So all these kind of simple questions they can ask chatbot, and then it can able to extract the data. It crawls not just our internal data, but also the real-time data across the social media and news feeds to provide the trade advisory for the traders. So these are the 4 key features or components that we have in our mesh. And right. So to conclude this, we can, if there are any questions, I can answer. So that's all I have for this, for the mesh. Thank you.
Thank you so much, Neelima, and please don't shy away from asking questions if there's something that you would like to hear more from our speakers. The next one on our list is Viboon. He is Director of Product Development to vCargo Cloud. I'm sorry for not pronouncing your last name, but I think I would get it wrong for sure. So he will talk about facilitating cross-border transit with Callewaert. So you have the floor.
Right. Thank you, Milena. Good afternoon, fellow delegates, colleagues, and at this WCO IT conference. Thank you for attending my tech talk. So I hope the slides is up. Yep. Okay. So today I'll be speaking about how my company, vCargo Cloud, from Singapore, helped to facilitate cross-border transit using our IT platform, the Camel One. So this is the agenda. I hope you, yeah, it's a little bit small, but I'll just say it out. So the first part, I'll explain a little bit about transit trade and why is it important to many countries. The second portion, I'll talk about our implementation in East Africa and how it helped the 5 countries in East Africa overcome the impediments of being landlocked. And third is that I'll talk a bit about our implementation in the Callewaert region, which is including Azerbaijan here, which I have been working with, and how we implement a regional transit system. Okay, so let's start with why is it important for the regional transit? Why is it that we have it, right? So out of the 200 over countries in the world, 49 countries are actually landlocked. So this works out at about 20% of the countries in the world. And in these 49 countries, there are 590 million population, which is around 7.66% of the world, right? So if you look at the map here, the yellow-colored countries are landlocked countries, okay, and including Azerbaijan, actually. Okay. So at present, 32 of these landlocked countries out of the 49 belong to a group called the landlocked development countries, right? And with these landlocked development countries, they face a challenge, basically without access to the seaports, right? So they have no sea, there's no seaport, and therefore the landlocked countries, in order to do trade, in order to export their goods, in order to import their goods, a lot of it depends on their neighboring countries, right? And with this comes an added cost and added time, right? So, therefore, there is actually a higher cost, higher complexity to trade for a landlocked country. And WCO actually recognizes this, right? Therefore, WCO actually published the transit guidelines. The latest version of the transit guidelines was published in 2017. In the transit guidelines, WCO actually had best practices as well as cases of how different regions implement their regional transit. Okay, some of the examples are the Euro-Asia Economic Union transit, the NCTS transit in Europe, and the TIR and the ETIR CANE implemented across Asia. Okay. But the issues is that of these three, right? Let me talk a little bit about some of the limitation of these three, right? For Euro-Asia Economic Union, basically there are only 5 countries, right? Russia, Kazakhstan, Kyrgyzstan, Belarus, and Armenia. So it's quite limited in scope. For NCTS, most of the regional transit systems of NCTS are in Europe. Of course, it's Europe plus some countries in the Eastern Europe as well, right? And for TIR, if you go to IRU website, the operating countries are mostly in Asia, continent Asia, and Europe. But however, there are very few of these countries are using ETIR, which is the electronic version of TIR CANE, right? So what about these countries that I've highlighted in red, right? The Central Asia countries and the African countries. They are left out in a way by these regional transit systems. So there is actually a need to do regional transit system for them. And that's where the funding agencies such as Trademark EAC and Asian Development Bank comes in. Right? The vCargo Cloud has been working with Trademark EAC to implement the single customs territory transit system in the East Africa countries, and working with the ADB Bank to implement the regional transit in the CAREC region. So I've been talking a little bit about Camel One and all that. Perhaps you're wondering what it is. It's actually a platform developed by my company in order to facilitate trade, right? So we use technology in order to promote government-to-government interaction, government-to-business interaction, okay? So we embrace the buy, ship, pay model that has been a reference model for the UNECE. Okay, so with this platform, we have built the transit systems around it. So now let me give you a case study of the East Africa community. So the East Africa community consists of 6 countries, right? South Sudan, Kenya, Tanzania, Uganda, Rwanda, and Burundi. Of these 6 countries, of course, South Sudan is a relatively new country. So of these 6, the other 5 are part of this project, the Single Customs Territory project. Okay. If you look at this map, there are 2 main corridors, transit corridors in Eastern Africa. One is the northern, what do you call it, the northern corridor, which goes from the port of Mombasa to Nairobi, towards Uganda, and then down to Rwanda. Right. The other corridor, which is the southern corridor, goes from Dar es Salaam port in Tanzania up north towards the lake and to Burundi and Rwanda. Okay. So basically, the main focus of the SCT project, which is funded by the Trademark EAC, is to create a seamless flow of goods and to enhance the EAC trade. Okay, so the gist is to reduce the cost and the time for goods to move from the ports towards the landlocked countries, Rwanda and Burundi, as well as Uganda. Okay, so there's also a shift from physical document to electronic document, and as well as it will help to enhance the compliance for the EAC region. Now, before our implementation, each of the customs authority are connected to each other via a peer-to-peer network. Okay, so for example, Kenya Customs Authority will connect to Uganda, Tanzania, and each of them will connect to each other. But there was a problem with this, right? Basically, for each customs authority, you have to connect peer-to-peer to 4 other authorities. And this makes it very difficult to maintain the integrity of the system, because each customs authority will tend to upgrade their system or even move their servers, right? So once that happens, the other 4 countries have to do a new setup, or they have to change their specification, etc. Right? The other problem was with the reporting. It's difficult to get an accurate report of the trade numbers. Right? So with the implementation of Camel One transit system, what we have done is that we have built a centralized server and installed it in Kenya, right, where all the customs authorities and the ports, the 2 ports that I mentioned before, connects to it. This solved the peer-to-peer issues as well as the reporting issues, because all the documents now flow through the central server before it's being distributed to the other countries. So in a way, a simple network diagram, it looks like this. We have the central server right at the top there, and then it connects to each of the country, right, via VPN, and then the customs authorities of each of the country will send messages to it before the messages get distributed. Okay. Okay, I'm sorry the graphics is a little bit small, but let me just explain how it works, roughly how it works for the first few steps. So if, for example, we have goods to export from Rwanda, Rwanda going through Uganda, Kenya, and then to the Mombasa port in Kenya, what will happen is that an export declaration will be filed in Rwanda. And this document will be sent electronically to the central server. The central server recognizes that this shipment is to be shipped out through Kenya port, through the two transit countries, which is Uganda and Kenya. Therefore, it will then send messages to these two countries saying that, okay, there's an exit declaration filed in Rwanda, and the cargo is coming towards the border of Uganda and Kenya. So that's the first arrow there. What happens next is that the truck will then move, and when it reaches the border of Uganda, an exit note will be filed by the Rwanda authority into the system, and this exit note will let the Rwanda authority know that the cargo has exited the country. When it enters Uganda, which is a neighboring country, the system will then update the status of the cargo for Kenya, Uganda, as well as Rwanda, okay, and so on. So that's how it goes. And in this whole process, it's all electronically done. The messages are handled by the system, and the intelligence is there to distribute the messages to whichever country that is involved in the transit. Okay, so what is the result of this implementation? By the way, the implementation went live in April 2017, right? So it has been live for a couple of years now. What we have found is that it reduced the turnaround time for clearance by 70%. There is actually a single weighing of transit cargo, and also the single checking. There's no need to be multiple checks anymore. And also the declaration of goods in and out of these 5 EAC countries are handled just once. Okay. Overall, if I were to say the volume of messages handled by the system was around 300,000 for 2018. 300,000 import messages and around 50,000 export messages for 2018. So with these numbers, you can see that even immediately you can tell that the import is much, much higher than export. So there's a need for the African countries to increase their export. Okay. Okay, so that's our case study for the East Africa countries. I'll go to the next case study, which we have done for the Central Asia. Okay, so Central Asia, there are 2 projects here. One is called the CATS, which is the CAREC Advanced Transit System, and one is the Customs Information Common Exchange, which is the ICE. Okay. Again, these 2 projects are funded by ADB, Asian Development Bank. Okay. So basically, the mission or objectives of CATS, the Advanced Transit System, is, as I said earlier, to create a regional transit document for the CAREC region, because there isn't one here. And the TIR, most of the country is using TIR, but they are not the eTIR version of it. Okay. And for ICE, the ADB commission the ICE project because they see that there is a need to build a system to showcase how the CAREC countries can exchange advanced information, transit information with each other. Okay, so the support for these CAREC projects comes from the CAREC Customs Cooperation Committee, the CCC. Okay, CCC is actually a group of all the customs committee in CAREC. There are 11 of them. In fact, the next CCC meeting will be in Tashkent next week, Uzbekistan. Okay, so they have identified 5 areas to improve for the CAREC region, right? If you look at the points, remove regional transit impediments is put under CATS, and to establish a data exchange mechanism is put under ICE. Okay. Beyond that, there are 3 more, which is the simplification and harmonization of custom procedures, the expansion of joint customs control, and then the upgrading of risk management system are the other 3. Okay. So as I mentioned, the main goals of the CATS is to enhance the security of the supply chain in the CAREC region, to help the transit flow more smoothly across the region, as well as to reduce the overall costs. Right. For ICE is to establish a protocol and standards for customs-to-customs interchange, to specify and provide the platform for transit information exchange, and to provide the platform for pre-arrival information exchange. So these are the 2 projects. Okay, if we look at the CAREC corridors, there are many, many corridors in the Central Asia region, right? What we have done is that we have identified one part of it for the pilot of the advanced transit system, which is circled in red here, right? The pilot countries consist of Azerbaijan, Georgia, and Kazakhstan. That's where the circle is, right? Okay, and the concept that we wanted to prove with this pilot is actually, 1, to have a single regional electronic transit system, all right, with the use of a common transit declaration. Second, is to have a comprehensive risk-based guarantee mechanism, right? Which is also part of what NCTS was doing. Third is to have a platform for the above documents, as well as to establish a specification for message exchange. Okay, so in terms of network diagram or topology, is a little bit different from the Africa one, right? The Africa one, if you remember, we have the central server, which all the customs connect to. So for Central Asia, it is a peer-to-peer network. Okay, one of the reasons is that in some of these countries, for example, Kazakhstan, there is a legal law that says that information from the country cannot be hosted outside the country itself. So therefore, in the transit system for this region, we have selected the peer-to-peer instead. Okay, so let me illustrate how it works. Okay, so for this pilot system, what happens is that the Camel 1 cross-border transit will be installed in each of the country, right, as you see in the diagram. Then, before the transit happens, the transit document will be submitted by the trader. And the trader has to buy a guarantee, a comprehensive guarantee from the insurer, and the insurer will upload the guarantee into the system as well. So when the truck starts to leave for the border, right, customs from the export office will go into the system to approve the transit declaration. Once the transit declaration has been approved, it will be sent to the other two transit countries that there is a cargo coming. So the truck goes to the border, and at the customs border office for the exporting country, the officer will identify the truck and consult together with the approved declaration that this is the truck, and as well as do their risk management and seal the containers, and then let the cargo cross the border. So once it goes, let's say the cargo is from Georgia, so now towards Kazakhstan. So this is the transit country will be Azerbaijan, right? So in Azerbaijan, the customs will then recognize that this is the truck that's coming from Georgia going to Kazakhstan. He will approve the transit before letting the cargo go. But once he approves, the system will know, and it will message the other two peers that the transit is happening and update their status. Okay, and so on. So whenever it reaches a transit office, messages will, approval status will be captured and shared with the other country's system until the office of destination where the cargo will be released. Okay, so that's an illustration of how it will work. So what is the current status, right, of this project? This project has formed 3 working groups. One is the legal and regulatory. Second is the risk management group. Third is the IT group. Okay, so myself, I'm in the IT working group, and my consultant colleague is in the risk management and the legal working group. So the pilot of the pilot countries right now, Azerbaijan, Georgia, and Kazakhstan, are talking about the signing of the trilateral agreement. Okay, so and meanwhile, the pilot system is under development and will be ready by the end of the year. Okay, so what are the key issues faced by CATS and ICE project? First is that there's a concern over legal implication, right? Because initially there's no transit declaration across, but then now we are going to do that. So all the 3 countries have to be able to validate or make it legal for the transit document. Okay. Second is that some countries are now moving cargo without the guarantees, such as Georgia. Georgia has no guarantee for a transit, right? And then with the establishment of CATS, basically they need to have a guarantee before they can move the cargo. Okay. And also the other considerations are that some countries, such as Georgia, is already signing up for NCTS. So whether they are implementing NCTS together with CATS is a question, right? As well as Kazakhstan belongs to EAEU system. So whether Kazakhstan, how the 2 systems will work together is another question, right? Okay, so my last slide, some parting thoughts. Okay, so through this experience, I think we have seen that there's no solution that fits all cases. As you have seen, the African case, they do not mind having a central server to simplify things. In the CAREC region, because of the law, the data cannot be hosted outside the country. Therefore, it's a peer-to-peer system, right? So the circumstances will dictate the solutions, right? So second, that no matter what, whatever new system that is developed, basically it has to follow the transit guidelines and best practices laid out by WCO, right? Without that, it will be difficult to integrate, right? And actually, integration is the third point I have there. Basically, Azerbaijan is at a crossroads of maybe at a crossroads of three transit systems: at the NCTS, the EAEU, and the CATS, right? Therefore, it's important for these transit systems, whoever develops it, to follow a certain interoperability. And actually, WCO has the perfect instrument for this. It is called the WCO data model, right? So as long as the transit systems that are developed and the custom systems that are developed follow the WCO data model, we can at least ensure that the data and interoperability can be there. Okay. So that's all. My company has a booth at booth number 10. If you have any questions or suggestions or answers, please approach me. I'll be there. Thank you. Oh. I think Milena has a question. Oh, okay, the microphone.
Thank you so much, Viboon. And I just wanted to break the ice a little bit. I think it's this room that is so big, and people are maybe not as comfortable to ask questions. So I'd like to ask, and apologies if I'm asking something that you already mentioned, because I had to go out of the room a couple of times. What I'm interested in is railway transit. So this is something, and customs railways cooperation is something that we in the WCO have not really been focusing much in the past. So it's an area that we're now exploring a little bit more. And having in mind that there are different requirements and different intergovernmental organizations for railways with different standards, and we're trying to identify how best to approach the question of speeding up movements of trains across borders and especially in transit. So I'm just interested to see to what extent have you maybe addressed this question under this project.
Okay, so the question is about rail transit and whether we have ever encountered or come across it, right? Okay. Basically, for this project, I have actually asked ADB why not we also consider rail. I think part of the reason is that for rail, it is much, in a way, it's less complex. Because rail, for each nation, there's only one or two rail operators, right? And for example, for if you look at the CRUX corridors, right, from China to Kazakhstan to, let's say, Russia or Azerbaijan towards Georgia and Europe, it's only a few rail companies involved. And what I understood was that there was already an agreement between these rail companies as well as the two ports, I think it's Aktau port in Kazakhstan and here, where they have an agreement already. Yeah. But I must admit that I'm not an expert in rail. I think we were at the time looking more on the truck transit instead. Yes.
Okay, we have another question from Jonathan Coe.
Thanks, Viboon. I was quite interested in what you mentioned about the guarantee with the insurance, and maybe because guarantee sometimes the trucker will get the guarantee with the customs, right? Yeah. Customs will issue the guarantee and then release the guarantee when the cargo exit, right? Yes. Then you mentioned about insurance. So can you elaborate about it? Is it instead of I buy guarantee from the customs, I buy insurance I buy guarantee insurance from the insurance company? How does it work? Thanks.
Okay, so typically a guarantee, in many countries, a guarantee is done through the customs, right? But that is typical of a transit within the country. So therefore, it is easier to get from a state-owned entity or customs. But when a transit is across multiple countries, basically, in this case, in our CRUX case, we wanted to involve the private sector. So therefore, we brought in the insurance company to be the guarantor. And these private sectors are best placed to do it because they can have a reinsurance with the other transit countries' insurance company. And that will save, in a way, the customs handling all the different transit guarantees with the other customs. So we modeled it by involving the private sector for this case. How do they agree to that? Yes, sir.
Hörmətli ümum, mən təşəkkür edirəm. Mən özümü təqdim edeyim. Mən Azərbaycan Respublikası Dövlət Gömrük Komitəsi Gömrük Nəzarət Təşkil və Ticarətin Asanlaşdırılması Baş İdarəsinin rəisi Səməd Qaralov. Nəzərinizə çatdırım ki, mən cənab Vink'in məruz elədiyi Çares dəhlizində üç ölkə arasında Qazaxıstan, Gürcüstan, Azərbaycan arasında söhbət elədi. Tranzit sistemin hazırlanmasında ekspertəm və bu sənədin hazırlanmasında biz bircə də bir neçə seminarlarda iştirak eləmişik, görüşlərdə iştirak eləmişik və təkrar görüşlərdə çox xoşdur və təşəkkür edirəm təkrar. Nəzərinizə çatdırırıq ki, artıq sizin elədiyiniz məruzədən fərqli bir sənəd yaranıb. Əvvəllər pilot layihə üçün 6 aylıq belə fikirləşilmişdi ki, elə bir sənəd olsun. Artıq o sənəd dəyişib. Üç ölkə arasında müqavilə hazırlanır. Azərbaycan, Gürcüstan, Qazaxıstan arasında və son görüşdə də həmin belə məsələ qaldırıldı. Bir sənəd artıq zəmanət tək sığorta şirkətləri yox, bütün maliyyə sektoruna daxil olan həm bank sektoru, həm sığorta şirkətləri artıq zəmanətçi kimi çıxış edə bilərlər. Və bu saziş NCTS-in prototipidir. Ona görə belə hazırlandı ki, artıq Gürcüstan Gürcüstan gömrüyündə 2020-ci ilin yanvar ayının 1-dən NCTS tətbiqi başlanılır. Azərbaycan bu sazişə həm o deməli yeni kompüterləşdirilmiş tranzit sazişinə, həm sənədlərin sadələşdirilməsi və unifikasiyası sazişinə qoşulmaq haqqında öz deməli fikrini bildirdi və biz artıq orada qeyri-formal müşahidəçi qismində iştirak edirik hər iki demək konvensiyada. Və biz də ona qoşulmaq niyyətində olduğumuza görə bu üç ölkə arasında hazırlanmış, bu hazırlanacaq və imzalanması nəzərdə tutulan bu sazişin də bu NCTS-in prototipində hazırlanması xahiş olundu ki, bir sənədin sonradan digər bir hüquqi sənəd formasını keçməsində çətinlik yaranmasın. Və Qazaxıstandan çıxan bütün yüklər Azərbaycan üzərindən keçib, Gürcüstan üzərindən Avropaya daşınan və əksinə Avropadan Çinə daşınan Azərbaycan, Gürcüstan, Azərbaycan və Qazaxıstan üzərindən daşınan bütün yüklər istəyir dəmir yolundan olsun, istəyir avtomobil nəqliyyatından olsun, hamısı bu vahid bir sənədlə, SAD sənədinin düz NCTS-də hansı formadadır, biz qaçısda da o formada planlaşdırırıq ki, vahid bir SAD sənədindən bəyan olunsun və bu sənəd təkrar olaraq nə Azərbaycanda, nə Gürcüstanda təkrar bəyan olunmasın. Bayaq sizin məruzənizdə slaytda göstərildiyi kimi hər iki ölkənin gömrük sisteminin və digər daşıyıcı şirkətlərində və zəmanət birliklərində imkanı olsun ki, vahid bir yerdən elə blockchain sistemin işləməsi də bu variantda işlənilir ki, blockchain sistemi bu prototipdə də məlumatların əldə olunması və gömrük nəzarətinin də risklərin idarə olunma sistemi əsasında həyata keçirməklə davam etdirilsin. Sadəcə bunu nəzərinizə çatdırmaq istəyirdim. Məruzəyə görə çox sağ olun və təkrar görüşdən şadıq və inanırıq ki, bu sistemlərin tətbiqi, bayaq sizin məruzənizdə dediyiniz kimi, həm CRUX-ın, həm Şimal-Cənub dəhlizi üzrə biz yetir pilot layihəsinə başlayırıq İran-Azərbaycan üzərindən, onun tətbiqi və həm də İMÇT Azərbaycanın qoşulması Azərbaycan üzərindən həm Avropadan şərbə, qərbə və Şimal-Cənub istiqamətində daşınan yüklərin həcmin artırmasına böyük xidmət edəcək və yüklərin gömrük sərhədindən tez keçməsinə xidmət edəcək. Çox sağ olun, təşəkkür edir və birgə əməkdaşlığının davamından da məmnun olacaq. Sağ olun.
Thank you, Mr. Samad.
Thank you very much, Viboon, and I think we have still a few minutes before the next and final presenter in this stream of Tech Talks. I think there were some questions for Frank Callewaert from Microsoft. Is that the case? You just have to raise your hand really high so that I can see it. Okay, no. That was not the case. Can I ask you a quick question? Okay, so I think something that always comes up and comes back to us, and something that we discussed also in the previous conferences on quite a few occasions, and which is quite relevant for all of the things that you were presenting. I'm sorry, can you it's going away with, maybe you can come here. So that keeps coming up to us when we talk about Internet of Things, when we talk about connected devices. The security component keeps coming up all the time. The discussions on cloud computing. What is a private cloud? What is an open cloud? What are the security of data issues that arise? And can you try to address that like in 3 minutes?
3 minutes, okay.
In 3 minutes, and give us a little bit more insight on that.
Okay. So there's a lot of questions in one question. So security is indeed, I think, a critical component, and I think technology should allow every part of the industry making sure that data is encrypted according to certificates they trust. So if you can encrypt data using certificates as an organization that you have created, that you manage, it doesn't matter where your data is in transit, because you need to access to the keys to be able to decrypt the data. And that is how we see things like IoT devices. We have the possibility on an IoT device to deploy your industry or your public sector certificates on the IoT device and only accept communication that is encrypted by the certificates that you have deployed. I could do the same thing with cloud. You could say, I don't trust public cloud, but if you manage your keys on premise and you transit your data over the internet, or you store your data in a cloud, as long as you keep the protection of your keys and the identity, because that's another thing, you protect your data, but you have also to decide and to configure who can access your data. Under what conditions can that be accessed? So identity and security management, encryption management of data is a key building block independently from your deployment model. As I said during my presentation, for us, cloud is not a place. It's a way of developing applications. It's a way of operating applications. It's a way of securing applications. Of course, the cloud has the advantage that it has unlimited capacity. You get performance when you need performance. You don't have to plan ahead. You only pay for what you consume. So if you introduce, I heard Mireille saying, we introduce 16,000 or 60,000 or 50,000 new IoT devices in one run, it's probably very hard to estimate how many data they will generate. So if you do that with own hardware, you have to cater for maximum capacity. While in cloud, you have that elasticity that can help you never running out of resources. Yeah?
However, it does always raise concerns, and so maybe for that reason you can give us just an example of the worst-case scenario and how rarely, hopefully, a breach would happen. So I'm talking about worst-case scenario of a breach.
Well, I cannot give a worst-case scenario of a breach as such. I think, again, this is not related to the way you use technology. There have been in the press stories about using a microwave oven or a vending machine that was in a factory where people could buy coffee or Coke, but that vending machine was an IoT object. And that vending machine was connected to the corporate network because it needed to signal to the warehouse or to the provider, you need to bring new Coke cans. But the fact that it was physically connected to an internet connection, connected to the factory, was allowing other organizations to come in using that vending machine software. So that is why we say you have to deploy your security on the edge, and you have to make sure that everything that goes in and out your environment is controlled by you, at least by certificates, by encryption technology.
Okay, excellent. Thank you.
Thanks
Thank
for
you
the
so much.
question.
And with that, now we're coming to the last in the four of our Tech Talks in Stream 1. So we have Professor Yao-Hua, who I think is very well known to the IT conference participants in the past. And he is a information and communication technology professor at the Department of Technology Policy and Management in the Delft University of Technology. He will be presenting to you on data analytics, innovation for customs risk targeting. So, Professor, you have the floor.
Thanks for the invitation and the opportunity to give a presentation here. So it will be in particular on projects that we did funded by the European Commission, various of them, and you might have heard earlier about the projects. Actually, I'm also program director of a master, the Customs and Supply Chain Compliance at Rotterdam School of Management. So we also link our research to educational programs, customs educational programs, also to innovate and how to learn new technologies like the one that we discussed today. So it will be in the broad sense on IT innovation for customs and actually also on blockchain and data analytics. And in particular, the core project, the previous project was on blockchain, or not only on blockchain, but on data pipeline. I will say more about that. And profile is on data analytics. Okay, so what is the challenge? Well, we are typically collaborating a lot with Dutch customs, so Frank Heijman was already referring to it, is that if you are in a country with a large logistic hub, well, the Netherlands or Singapore, we are facing in particular e-commerce challenges, so that it leads to an increase of custom declarations of about 15% annually. And also we are in Europe, so we are also facing challenges of Brexit. So that is again another 15% annually increase in declaration. Dutch customs, well, the numbers Frank was also already referring to, it's large, so it's in the range of 160 million custom declarations per year. And one reason being is that actually the total volume of trade in Europe is going via the Netherlands, 30%. So that also drives up the number of declarations. And it's expected, Frank was referring to 400 million, if you extrapolate even further in a few years from now, then it could go up to 500 million, even perhaps 600 million per year. And the issue is there, but I think that is a common understanding here in this conference, that it's impossible to process. And even in the Netherlands, for instance, we get an extra, the Dutch customs, they get an extra 900 officers, but it's really, it's not only hands that can deal with this, but you really need a lot of extra controls, smarter controls with IT innovation. And Frank was already referring to that, Frank Heijman, Internet for Logistics. So probably you have seen this picture before. The basic idea is that it's the green bar, that's the Internet for Logistics, and the whole idea is from the right-hand side, that if goods arrive, let's say in Europe, in the Netherlands, that you are able to use this, so you have of course the mandatory declarations, so the import declaration, but also the entry summary declaration. But then in addition that you get real source data, so to cross-validate the accuracy of the data on the import declaration and the ends, and in particular then you go to the seller of the goods, so the consignor, and really get the real data, the purchase order, the invoice and the likes to cross-validate. And in particular, for instance, with the ends, this is a typical problem that the ends is typically agent to agent, so you only see the freight forwarder on the entry summary declaration, and you don't see what's called the true buyer and the true seller. So what you would like to have is access to the electronic invoice, the purchase order, and but also, for instance, the real packing list of the container. So the moment it was stuffed, for instance in China, that you really have a report on that and that you can really verify that the goods that were claimed to be in the container are really in the container. So this is the kind of data, and the green bar is basically providing access, so in this Dutch customs, for example, to get the data, to go to the systems of those companies and to get the data. It's segmented because the whole idea, the whole logic of the data pipeline is that it's not a thing that is built by Dutch customs or any other customs administration, but in particular it's by interlinking the IT systems of the companies and the organizations that are in a supply chain. So that is the challenge to make it happen. Now the interesting thing is the slogan is of course get data from the source. Customs should use more trade data to cross-validate accuracy, and in particular it's about invoice, purchase order, packing list, that kind of information. And the interesting thing is that what we learned from our projects is that companies are by now willing and able to do so. And one example was, for instance, in Kenya. So we did on one of the cases in core, that was the import of roses from Kenya to the Netherlands, and it's huge, it's about 90 tons a year, so it means 5 flights a day, going from Kenya, from Nairobi airport to Schiphol. And it was, one of the questions was to the growers in Kenya, are you able to, are you able to provide the electronic invoice? Now the interesting thing was that they say, well, no problem. So they were using, it was a mid-sized company with about 500 people, but they said, well, we're running an ERP system, so you can get the invoice, the purchase order, it's all in XML format, so it's to that extent it's standardized, and you can get it whenever you want. So we are willing to do, and we are able to do so. And of course willing in the sense that if it provides more facilitation, expedited treatment in the Netherlands when the goods are imported. And this is possible because the Dutch customs, if they have more information about the goods, then they can de-risk and there is less need to do a physical inspection or to do any X-ray scanning on the goods. Now, the important thing is, so companies are able to provide this data. So that's what we learned from our projects. And they are able, and the packing list and purchase order data, they are all available and they are willing to share that. Trade data is available also in IT systems of companies. And there is, of course, on the government side, port community systems, single windows. Well, you had many presentations on that, of course, in port community systems, they have a lot of information. Single windows, there's basically worldwide, perhaps not a fully developed single window, but it's going fast now and there are a lot of developments. And on the other hand, there's also a lot of data available in all kinds of global IT systems, like Intra, global data sharing platforms like Intra, Descartes, GT Nexus, SAP, and IBM is also as a technology provider involved. So the key issue is give border inspection agencies access to company data by facilitating public-private information exchange. So the whole idea is that these data pipeline is really a thing that is by collaboration with the trade that you motivate and create incentives for them to participate. Well, there is a lot of existing ICT. I take the example from the Netherlands. So we have, for instance, a single window. It's called DigiPort, but there's a whole, so it's integrating also with phytosanitary inspection, with the customs declaration system. In the Netherlands, that's quite one of the interesting things is that we also have an electronic phytosanitary declaration system. And the same holds for instance, Kenya. So more and more countries now, although worldwide most of the phytosanitary declarations are paper documents, but in some cases, so China, for instance, they are also very active. Various countries are now really developing the electronic digital versions of the phytosanitary declaration system. The other thing is, of course, port community systems. So we have in the Netherlands port base, they get more and more in also facilitating or supporting trade, but also exchanging custom-related information, like custom clearance messages. To a large extent, they provide that functionality to Dutch customs. So it gets integrated. And the same holds for Cargonaut. It's the community system of the Schiphol airport. And again, I already referred to that, logistics and supply chain management, software systems. So there's a lot of those chunks, let's say, of the components of the data pipeline are available. Well, the next step, it's not full data pipeline visibility, so that's not still science fiction, but it's getting there in steps, and that's the interesting thing. Now, one next step that was made in core, so you already, Scott Todd was talking about it, the trade lens, and that is a nice example of what was developed in the core. Now, the interesting thing about the trade lens is that it's basically, it consists of two components. The one is a shipping information pipeline, so that is basically logistic events. And that is the top part. So on the top you see the typical steps that are taken with export and import, from consignor to consignee basically. And all the events, all the logistic events are there, but also in addition, special events were added in Trade Lens, in particular for the packing list. So that is on your, I have to see, on your left-hand side. So that is actually one specific logistic event, or it is not typical logistic, but it was added, and that is stuffing the container, and that is closing the container. So there's special events were added that are very much custom risk related. So those events are also tracked. And the shipping information pipeline, that is basically, because it's huge volume data, that is done with a service-oriented architecture. And all the related documents, so for instance a packing list or a bill of lading or an import declaration, what you see on the bottom, they are in a blockchain environment. And so it's also the invoice, the purchase order and the like. So they are stored, so it's immutable, you cannot change it. Anyway, it's when you change it, it's immediately noticed, so that's of course the blockchain. What is interesting is that in this case, the decision was made to build it on Hyperledger Fabric. Well, you might know that there were various comments on the blockchain. And the interesting thing is actually that many people make the comparison with Bitcoin and with cryptocurrency when they talk about blockchain. But that's actually to some extent confusing, because the Bitcoin and the cryptocurrency, yes, it uses blockchain, but there was an observation, and various presenters were referring to that it has huge energy consumption. And that is actually only, there are various types of architectures for blockchain, and that's only when you have what's called mining nodes. And I'm not going to explain in detail what it means, but it means that if you have a lot of nodes, so if you have a blockchain network that indeed has millions of nodes, as is typical for cryptocurrency, then you need that. Then you need a special consensus mechanism, as it is called, that is based on mining nodes. And mining nodes, they use a lot of heavy computation, and that requires a lot of energy. But if you do it with fewer nodes, then you can really reduce the energy consumption. But what's even more important, you can increase the computational power. So you basically the processing power. So you can also process much higher volume of data in these blockchain networks. And this is typically what you can do in Hyperledger, and in particular in the case of TradeLens, it was decided to have only a few nodes. I'll explain that later. First, what does it look like? So the shipping information pipeline, the interface, what you see here, it's typically following the event. So this was a container, and it was tracked from India to Rotterdam, and all those events are real-time, or they were real-time recorded. And the interesting thing is because they have very active participation, I will say more about that a bit later, from Maersk, of course, because it's an initiative of Maersk and IBM. And the big thing is that they have basically all the data of the Maersk containers in it, and also of the terminals. So, for instance, APMT is also, many of the APMT terminals are also involved. So they really can follow, and they have all the relevant data, and they can report on this. So this is the interface of the shipping information pipeline. And the next is the paperless trade. So that is really the blockchain component. And it has two advantages. The one is the immutability. So you cannot change, basically. You cannot change the document. You can always check whether in the network it's really the original document. And this was an export license actually from the example. So this was from the Kenya export case. And the interesting thing is that typically now it's, when we were doing the core project, it was changing from the paper-based version to now more and more electronic. But in the initial phase, of course, and that will probably be familiar to you, it basically took 3 validation steps. So KRA, CAFIS, so Kenya Customs, they had to validate the document. Then also CAFIS, phytosanitary inspection in Kenya, had to validate. And also the ministry, they had to do a quality control on it. So basically 3 validation, and each validation step took about half a day, because you had to go there to the office to queue up to get the validation. Well, this is of course familiar to you all, but the nice thing is that in this case a mobile app was developed, and that they could do the validation basically with the mobile app, and then it's a matter of seconds. So they could, and that is the second interesting thing what you can do with blockchain, is that you can use the blocks in a chain, not just the document, it's not just data, but you can also use it as a validation step. So this is an example where it was used for validation. So this is the architecture. The architecture is done in a way that you can really process it at large scale. So on the left-hand side, what you see is the architecture for exchanging the logistic events. And that is basically a service-oriented architecture, so that's very robust, and it is very scalable IT architecture for exchanging data. And that is, so for those events that are not, let's say, too sensitive, then you can use for the logistic events, you use that. And for the documents, typically, you use what is on the right-hand side, and there 3 nodes are identified. So, and that is the interesting thing. So in our piloting, what we noticed is that actually if you take a trade lane, if you take a supply chain, then typically there are only a few nodes that really are exchanging the data. So typically you have the typical example is that you have the seller that has relevant data and owns data and wants to secure it. Then they have a freight forwarder that acts on behalf of them, and for instance the third node, a carrier. So there basically it turns out that for each trade lane basically you could argue that you only need a few nodes. And as I explained before, that means that if you can limit the number of nodes, then you also can use other types of blockchain, other architectures that don't require mining nodes, and that makes it much more scalable. So that was, and in this case, so it's called a channel. So basically for each It was not really that for each specific supply chain or a specific trade you make a special blockchain, but it's typically that you differentiate between carriers, so that is one way, or freight forwarders. This is in the network state actually early January, so it's already growing now. And already in beginning of January, or in 2019, they already had a very active participation. First of all, so they had 350 million logistic events in the system, and that's of course taken into account that they have all the MERS containers at that moment, and that each container comes on average with about 200 logistic events and documents, or documents. So then it adds up and you get to big numbers. And basically 1 million per day is added. Also, they have active participation with various customs. It's piloting, so at the moment, in the sense that the system is already operational, but still interfacing and the like, that's still going on. And that's with Australia, with Bahrain, Canada, Dutch customs is very, I will say more about that. With Ghana, for instance, Saudi Arabia, Peru, Singapore customs there, and even with Turkey. Now, it's a global rollout. So at the moment, there are some large global companies that participate, and they really provide data. The number of containers, it's well over, by now, well over 1.6 million. It's really huge. And as already mentioned, so the large number of container events and documents. Another thing is active piloting. So what will happen actually, so that's developed now and will be tested, is the custom real-time information system. So it's called CRUX. And that is built, basically developed by Dutch Customs to connect in general to data pipelines. But one of the first they will test with is TradeLens, and then see if they can really process these extra data that is available, that will become available via the data pipeline, via TradeLens, and to cross-validate then the import declaration and the ends. Now the interesting thing is that it started with Maersk, container carrier system. So they have data from container carrier systems, Maersk and Hamburg Süd, of course, because they merged already. And a big breakthrough was, of course, in June 2000, so a few weeks ago, that MSC and MCA will join. So it's really building up now, and that together is basically, it's about 50% of the worldwide container volume that will be then, data will be available in the TradeLens system. Various container terminals are also actively participating, and in particular APMT terminal in Rotterdam. So it's fully automated, so it's collecting all kind of data in an automated way, and also making that available via TradeLens. Some piloting is also going on in Singapore, but also, for instance, in Peru. So in that sense, a lot of things are going on. Also, what's very important to link port community systems, because basically, okay, I have to speed up. They are the local data providers. And there are pilots with other customs administrations. So I will go. So it's basically, it's benefit. It's clear that you can use it as a data pipeline. It will be piloted, among others, with the customs real-time information system. And also the European Commission is doing some pilots with blockchain, with excise actually, and temporary storage. Okay, with that I will, hopefully in 5 minutes, the data analytics then. That is basically the profile project. In the profile project, it started in August 2018, and we're developing data analytics for customs risk targeting and very active participation of Belgium, the Netherlands, Estonia, Norway, and Sweden, and then Cross-Border Research Association is coordinating it. And they are developing data analytics. One example, so Dutch Customs pilot, that is on to check prices on publicly available data of e-commerce goods. So basically, go to the e-commerce websites, find prices, and compare that to what the stated value on an import declaration. Well, you probably know that in many cases with e-commerce goods, the prices, the valuation is not correct. So that helps enormously. It will be basically data analytics to do an automated search of these e-commerce websites and then to compute the average price from these websites. And in particular, it's intended to be a support tool for customs targeting officers so that when they have to make the decision about selection, whether to inspect or not, that they can have this extra cross-validation of the accuracy of prices. And again, this will also be tested in the custom real-time information system. The other thing is the Belgian customs. And they are very much on what they call operator profiling. And the typical thing being, so this is their CIDA. CIDA is their selection engine. This is the innovation. This is the next step for it. And that is basically in profile we will develop. On the one hand, on the left-hand side, on the right-hand side, it is basically applying, so that is the CIDA right now, without the black boxes. So that is the current CIDA. That is applying risk profiles, also taking into account operator status, so that is already in the existing system. What we will add is based on control feedback and historic declaration sets, machine learning, apply machine learning and get new patterns. And a typical example is declaration behavior, that if you notice that an importer or an exporter, is switching every time it's inspected, then this is a suspicious behavior, and that declaration behavior will be taken into account. Another thing is that we will use also machine learning to do analysis on external data, and in particular external data from big data that is available from maritime. So there are various organizations providing that data, and we will use that as input, but also TradeLens will be used as input data for developing that type of data analytics. Another thing that's going on, and that was unfortunately I couldn't put that in these slides because that was a very recent decision, is to also go, we will test also the development of data analytics in one country and then see if that can be transferred to another country. So, for instance, between the Netherlands and Belgium, we will exchange the data analytics, that is the methods that are developed, and test them. So, for instance, when they are developed in the Netherlands, then test them on Belgian data sets. And for that, we will also make a platform that will be done by the Joint Research Center that's also participating in this project. And they will make an IT platform that is able to exchange that data and also to exchange risk-related data. So that is kind of anticipating on new developments that will take place in ICS2. So this is what, in particular in Belgian customs, so what also the sharing, not only of risk data, but also in between at least EU customs administrations, to share also the data analytics methods, and then to see, okay, how, in what sense can you benefit from sharing that and how to do that. Now the other thing is that we will do a general value, what we call value analysis, is that typically when you do various data analytics at various stages, that you notice that it's complete different technology, the algorithms that you use, the data analytics algorithms are complete different, but also that to see what is the impact. One example, so the first is that you have data analytics on basically the declarations and the control feedback, so that's basically on internal data. The other thing is, the next step is typically what you do is, examples I was giving about Dutch customs, but also Belgian customs, using external data to cross-validate the accuracy. So that's yet another type of data analytics that you use for that. And then, of course, what's also in many sessions, there was about, for instance, inspection, X-ray scanning, that requires complete different type of data analytics like image recognition and unified file format, UFF, and the likes. So that's yet another complete different way of approaching. And sorry, one thing, so the thing about this is, okay, how do they impact each other? So if you really do it through the custom clearance process, where is it most useful? Okay, final observation, and then so basically the question is the decision points, where are the data analytics benefits most useful? And one example is that, of course, you can use data analytics to decrease false positive inspection. Now, typically, in most countries, it's about 94% false positives, so it means that targeting officer is selecting goods for inspection, but when it's inspected, it turns out nothing is wrong. There you can use machine learning to improve that. So basically you have less ineffective inspections and you increase your customs efficiency. A complete different thing is, of course, to use data analytics to decrease false negative inspections. So that means what you have missed, like catch more illicit trade. And the point is, of course, that the different types of the data analytics, so it requires complete different training data sets. In particular with false negatives, you need all kind of data that you don't have in your database, because it's basically about what you have missed. So a typical thing is with narcotics, you have to use macroeconomic data to know, okay, what was actually sold on the market, to have an indication about what you think was imported, and to verify that against complete other data set about what your estimate is, what was sold in the market. So this is the kind of observations we make. And another thing is that we also look into the resource limitations. Because the point is, you might have more true positives, but at the end you have to be pragmatic and also understand that you have only a limited capacity to process it. So if you have more true positives, it has to be balanced with administrative after processing, because that takes extra time. If you have more true positives, at the end you also have to process that, and you need enough staff to do that. So we also look in particular in the trade-offs that have to be considered between data analytics innovation and customs resource limitations. Okay, with that I would like to end. Yeah.
Any questions from the delegates? I guess that is not the case.
No?
Okay, thank you so much, Professor Tan, and join me in a round of applause for his presentation. We will be continuing with the sessions, with the last session for the day in about 10 minutes. You will hear the ring outside if you want to still take an opportunity to go for a little break. So in about 10 minutes, we'll be back in the room to have our last session. Thank you.